Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video on machine design or design of machine elements, I have taken up a problem on the design of a ball bearing. Friends, in design of ball bearing, we have got two varieties of problem, and in the first type of problem, based on strength, the shaft diameter or the bearing diameter will be given, and you have to select suitable ball bearing from the machine design data handbook. And friends, for your kind information, for both design of machine elements 1 and design of machine elements 2, that is DME 1 and DME 2, I make use of the machine design data handbook authored by Dr. K. Lingayya of Karnataka, and this book is published by Suma Publishers, Jayanagar, Bangalore. Friends, in the design of ball bearings, I have taken up the first type of problem wherein the shaft diameter is given. So we call it as type number 1 problem for the purpose of identification of the problem. Friends, when you say design of ball bearing, you will have to find out or select from the manufacturer's catalog based on the load to which the ball bearing is subjected. So generally there are two types of load. One is the radial load and other is the axial load or the thrust load. So in the design of any of these ball bearings, the axial load will be given to you, the radial load will be given, and it will be specified in the problem what is the service required or for how many years this bearing will be in use and at what RPM the shaft is to rotate. So friends, let us see the problem for today's video. Select suitable SKF ball bearings to sustain radial load of 3000 Newton and the thrust load of 2000 Newton. The service imposes light shock and the bearings will be in use for 3 years at 10 hours per day. The speed of rotation is also given. Friends, the design procedure for this involves around 4 steps. So in the first step, we go through the problem and analyze to which category this problem falls. That is, whether the diameter is given or not given. So in this case, the diameter is specified. So in step number 1, I am going to find out the life of the bearing in terms of millions of revolution, which I call as MOR, that is millions of revolution. Based on the duration for which this bearing will be in use, we are going to calculate in step number 1 for how many rotations the shaft has to rotate or bearing has to rotate before it is discarded. So friends, in step 1, we will use or we will find out to calculate ln, the life of bearing, in millions of revolution, in millions of revolutions, which is called as millions, that is MOR, millions of revolution. In short form, I call it as MOR. So friends, how to calculate this ln? Friends, in the problem it is given the bearing will be in use for 3 years at 10 hours per day. So I'll write down ln equal to 3 years at 10 hours per day, and The speed of rotation is given to be 1200 rpm. 1200 rpm. Friends, we will convert this period of 3 years or whatever may be the given period in terms of revolution. So friends, I am going to write down this as 3 years. I am going to convert that to days, 365 days. This will give you total number of days into hours. That is total number of hours. Hours you will get. This is 365 days into 3 years. Total number of days into 10 hours per day. So it will give you so many hours. So this is 3 into 365 into 10 hours. I am going to multiply it by 60 to convert that to minutes. So finally friends, this is 3 into 365 into 10, so many days, hours into minutes, that I am going to multiply by 1200 rpm. 1200 revolution per minute. So friends, this will be the revolutions you get if you multiply this. So this total value I am going to divide by 10 to the power of 6 to get the answer of this ln in so many millions of revolutions. And friends, this works out to 798.4 MOR, millions of revolution. In other words, this implies that the bearing which has got the shaft diameter of 55 millimeter, based on these loads, to sustain those two loads, it has to make so many millions of revolution before it is discarded or before it is changed or before it is thrown out. So friends, calculation of this part, that is life of the bearing in millions of revolution, is a very important step, because if you just go wrong in simplifying any of these, you should be very careful. So check this answer twice before we go to the second step. So we have found out how many number of revolutions or millions of revolutions the bearing has to make before it is discarded. This is a very important step. Friends, in step number 2, we are going to select bearing or selection of bearing. Selection of bearing. Friends, this is a very important step again. Here friends, we have 3 types of bearings. One is called the light series, that is called 02 series. Second is medium series, that is designated by 03. And the third one is heavy series, that is 04. So 02, 03, 04. Light, medium and heavy series. So friends, what do we do in this? We have an equation which gives life of bearing as ln is equal to c by p to the power of 3. This is available in machine design handbook. The life of bearing is c by p to the power of 3. Excuse me. So here what we do, the diameter is given to be 50 millimeter. So we have the choice to select. We have select 50 BCO2, 50 BCO3 and 50 BCO4. We have the choice to select any one of these 3 bearings. This 50 indicates the diameter of the shaft that is given in the question. Friends, we make use of this formula. So to make use of this formula, we should know C, we should know P. I will tell you what these terms stand for. So We start with this, that is light series, medium series, and this is heavy series. So we go in order from light series to medium to heavy series. Find out the value of that bearing, light, medium, and heavy in order till you get this Ln value, the life of that bearing, one of these. We should have a life equal to 798.4 because the bearing we select should have a life of 798.4 millions of revolution compulsorily. It can never be lesser than that. So friends, here we have to know what is C, what is P, get the value of C and P or calculate these two and find out the life of this bearing. Check this with the answer 798.4. Next, if you are not satisfied with this, go to this and then finally go to this. So one of these three should be able to satisfy the condition that Ln is equal to or greater than 798.4 in this problem. So here friends, C stands for the dynamic capacity or dynamic load of the bearing. And this friends is available in the chapter on design of bearing. There is a big tabular column and this is available in the machine design data handbook. Whatever may be the author, whoever may be the author, you will have a value for this, the dynamic capacity, and that is given to be equal to 23,200 Newton. So this value is always obtained from the table for the bearing you are considering, because I am considering that is bearing number 1, that is 50 BCO2. So friends, this P is an equivalent load of the radial and axial loads. A load which is equivalent to these two. So this is given by the formula x times Fr plus y times Fa. This is again given in the machine design handbook. So the load P, which is equivalent of the radial load and the axial load, is given by this formula. Friends, so to find out this P, we need to know what is x, what is y. Because in this, the radial load is given to be. The radial load is given to be 3000 Newton. The axial load Fa is also given as 2000 Newton. That will always be given, without which you cannot design the bearing. So this axial load is also called as the thrust load. So they mean the same. Friends, let us find out what are these terms x and y. So I will say in the same step to find x comma y. These are the constants. Friends, these terms x and y in the equation of P stand for the values, and there is a table given like this in the machine design data handbook. There is a column by name Fa over C naught, there is a column X, there is a column Y, there is a column E, and there also you have got what is Fa over Fr ratio. There is a tabular column. There is a manufacturer's catalog. You have a tabular column similar to this. Friends, to know Fa over C naught, we need to find out what is the ratio Fa over C naught. Friends, for the given bearing, Fa over C naught is equal to Fa is 2000. C naught from the data handbook is 38,000. That is for 50 BC O2 bearing. If you refer to the machine design data handbook, you get this value, and this works out to point FAOC not 0.086 point, sorry, this value is 23,200. Sorry. So this value of C naught is obtained from machine design data handbook corresponding to 50 BC O2, this value. And this works out to, friends, 0.67. Sorry, this is FAOC naught works out to a value that is C naught is 0.086. You can check this answer. Your FAOC naught we have got. And also we have to find out what is FA over FR. The ratio of the axial load. The axial load or the thrust load is 2000. The radial load is 3000. And this works out to 0.67 FA over FR. Friends, corresponding to FA over C naught equal to 0.086. And this is a value. You have got the value of E corresponding to, you can say, corresponding to FA over C naught is equal to 0.086. Actually, you get 0.084. We have in the table, nearest table value is equal to 0.086. So, you find out this ratio, find out the value of this works out to 0.084. Check in the table. In the table it says a value 0.084 is a value available in the table. 0.86. That's the nearest table value. Corresponding to that, friends, you have got the value of E is equal to 0.28. So in the same column, you will get the value of E is equal to 0.28. Now friends, we are going to compare FA over FR with this E, and I will write down here, comparing FA over FR with E, that constant E again, we find FA over FR is 0.67, we have calculated, is greater than E, which is equal to 0.28. This 0.28 is obtained from the table. This value you have calculated, you have to have a comparison. So for such a case, friends, we get from the same table, we get x is equal to 0.56 and y value, the constant y, is 1.55. See, all this procedure we are following to get the value of x and y to obtain what is the equivalent of these two loads. So friends, we know x, we know y, we know FR, we know FA, and hence we will calculate what is P. P x FR plus y times FA. And this is 0.56 into radial load is 3000 plus y is 1.55 into axial load is 2000. Friends, this value works out to 4,700 Newton. So the equivalent of the radial and axial load has to be calculated in all the problems, and this is the value you get. But friends, this is an average value, and here whatever the value of P you get, that has to be multiplied by a service factor, and this service factor depends on the type of service. The service may be a light shock, a medium shock, or a heavy shock. In the question it is given as light shock, and so we are going to multiply this P by a factor 1.25. If it is a medium shock, we multiply this by 1.5. If it is a heavy shock specified in the problem, we multiply it by a factor 1.75 to 2. So since it is light shock, I can say here, considering light shock, I told you the above value is to be multiplied by 1.5. Therefore, P is equal to 4700 multiplied by 1.25, the shock factor, and this works out to 5975. 5975. So many, it's a load, so many newtons. This is the equivalent of the radial and axial load. Friends, we have the value of P, we have the value of C, and friends, now we can calculate. Therefore, for 50 BC O2 bearing under consideration, comma, Ln is equal to C by P to the power of 3 becomes equal to C value, friends. The value of C is known to you, is C by P. C is 38,000. Sorry. So you get the value of this C, and the value of P is C value. Okay, you will have the value C, and this is available from table again. C value. This C is taken from table. And the same 50 BCO2. So this value can be taken, and P value we have got as 5975 to the power of 3. Friends, if you simplify this, you get Ln for this particular bearing equal to a value, Ln equal to 211 point something. So I will write down this value, 202.73. 202.73 MOR. So I will tell you what is the meaning of this. Friends, this Ln equal to 202.73 means that the bearing which you are analyzing now, that is 50 BCO2, under this loading condition and this shock, running for this many years of service, will have a life equal to 202.73. It's a very important concept. That is, the required life is 798.4 millions of revolution. But the actual value of Ln through which the first bearing will run is only 202.73. And hence we can say that the bearing 50 BCO2 bearing 50 BCO2 will have Ln equal to, what's the value? That is 202.73 millions of revolution, which is far lesser than Ln required. So we should always make a comparison between the value you obtain in the first step and every bearing you are analyzing. That is to say, this bearing is not suitable and hence not selected for the problem under consideration. So this is ruled out. we cannot take or use this bearing 50 BCO2 for this application. So what is to be done now? Friends, the procedure is to be repeated with the next trial, that is trial number 2, wherein we take 50 BCO2 over O3 we should take. So trial number 2, we consider 50 BC O3 bearing. O3 is medium series ball bearing having 50 millimeter dia. Friends, we repeat the procedure whatever we have followed for the first bearing we have learned is 50 BCO2. So we'll go ahead as usual. Again, Ln is equal to C by P to the power of 3. So this formula we are going to use and find out what is the Ln for this. So friends, for this friends, we have got this C we have to find out and P we have to. P is equal to XFR plus YFA. I know FR, we know the value of FA. X1, Y has to be found out. To find out X and Y, we have to follow the same procedure, the previous procedure, for the given bearing FA over C0. For the given bearing, FA over C0 value equal to 0.053, where this C0 is 38,000, where C0 is equal to 38,000. See, both C0 and C are available in the same table, the value one adjacent to the other. So if you make use of this FA, the axial load is 2000 and this is 38,000 from the table you get, and this works out to 0.053. 053 it is 0.053. You get the value. Now we have to check in the table what is the value of the FA over C0 available from the table. So I will say here the nearest table value, I will say NTV of FA over C0 is equal to 0.056. See, we have calculated FA over C0 to be 0.053. Refer to the table. The available value of FA C0 is 0.056, for which E is equal to 0.26. Y is required. So based on E, we should be able to calculate what is the value of X and Y item. Also, friends, we have FA over FR is equal to, that is 2000 divided by 3000 given in the question, that is 0.67, because FA over FR is a constant for a given bearing. Whether you are trying O2 series, O3 or O4 series, the value remains the same. So after getting this, I am going to compare with E. Comparing FA over FR with E, we find FA over FR, you will say, we find that FA over FR is 0.67, which is greater than E, which is equal to 0.26. So whenever this ratio is greater than E, the X value will be 0.56 always, and the corresponding value of Y adjacent to that column X, you have the value Y is equal to 1.71. So friends, we can find out what is P. The equivalent of radial and axial loads is XFR 0.56 into FR is 3000 plus Y times FA. Y times FA is 2000. And here itself I am going to multiply this by 1.25. I told you that is the shock factor. For the light shock, this value has to be multiplied by 1.25. For medium shock, it has to be multiplied by 1.5. And then for heavy shocks, the value of this multiplying factor varies from 1.75 to 2. So friends, this works out to a value finally 6375 is the value. That's so many newtons. So we get this value P equal to 6375. Friends, now let us find out what life this bearing will have using the formula Ln is equal to C by P to the power of 3, and we know the value of C from the table, and this can be obtained from the table C, and then the value of P we have got is 6375. The whole thing raised to the power of 1 by 3 will give you the life of the bearing. And friends, in this case, this answer works out to 911.01 MOR. What is the meaning of this? We are analyzing the bearing, that is 50 BC O3, and this bearing based on this load condition will have a life equal to 911.01. And when we compare this with the Ln value required, that is we want around 798.4 MOR. So we can say Ln equal to this 911, which is far greater than Ln required. That's equal to 798.4. So we want to have a life of 798.4, but this bearing 50 BC O3 will have a life of 911.01 MOR, and hence, since this is satisfying the condition that it has got a life which is far higher than the life required, and hence we select 50 BC O3 bearing. And in the first and second column, they will give you the values of this diameter, etc. So I will write down a simple sketch of a ball bearing. So it will have and this is the shaft diameter they have given you, that's equal to 50 mm. This is capital D, the maximum dia, that's given to be 110 mm. This is from the table we are getting all these values corresponding to 50 BCO3, and the width of the bearing B is equal to 27 mm, and the fillet radius at these four corners we will call it as R. R is equal to 2 millimeter. That is the fillet radius, and this is the shaft dia. Friends, once you have this bearing size selected, you will get all this information from the machine design data handbook under this design of ball bearing chapter. Friends, suppose even after trying the second bearing, that is 50 BCO3, you are getting a value lesser than 798.4, which is the required value, then you have to repeat the procedure taking 50 BCO3 O4, that is the last bearing, that is heavy series, and I am very sure one of these three either O2, O3 or O4 will give you a value which is a life equal to or greater than the required life. Friends, I hope the presentation is interesting. Please go through the complete video, and a problem of this type you will have to work out 2 3 problems, then only all this procedure will come to your mind and you can remember this forever. Friends, after watching this complete video, if you find it interesting, please share the information with all your friends and have a wonderful day. Thank you very much.